Let's take a look at this clip from the movie The Incredibles. We'll enjoy the glamour first, and then go back and discuss some of the relevant physics. We'll be answering two questions today. First, is it realistic that Mr. Incredible can stop the train in the amount of distance that he has? And secondly, we'll evaluate as to whether or not this process is safe for the passengers. That is, do they experience enough horizontal deceleration for them to feel some adverse effects? In this scene, we have an elevated track on which a train is traveling. It has a weight of 450,000 kilograms. It's traveling to the right at 27 meters per second, and Mr. Incredible has a weight of 130 kilograms. He stops the train in 30 meters. We know that in all scenarios, energy will be conserved. We can express this with the following equation. The energy that the train has in the beginning, its kinetic energy, will be equal to the work that is done. That is the energy dissipated in the process of stopping the train. In particular, work is defined as a particular force applied over a certain distance times the cosine of the angle in between them. We can express this as 1/2 times the train's mass times its velocity squared. And we set that equal then to the force of friction times the distance over which the force is applied times the cosine of the angle in between them. Let's take a second to figure out how we calculate the force of friction. Here's a free body diagram for Mr. Incredible. He has a weight force and a normal force. His weight force is equal to his mass times the acceleration of gravity. That is his weight, 130 kilograms times 9.8 meters per second squared. Because Mr. Incredible is not accelerating in the y direction, his weight and normal forces are equal and opposite. His frictional force opposes his motion and can be expressed as the kinetic coefficient of friction times his normal force. We can now calculate the kinetic coefficient of friction that Mr. Incredible must have to stop the train in this distance. We get an astronomically large 4,291, which is much greater than 1, which is already a very high coefficient. It is therefore unrealistic to stop the train in this distance. Now, let's calculate the acceleration or the deceleration that the passengers would feel as Mr. Incredible brings the train to a halt. We know that twice the acceleration times the displacement is equal to the final velocity squared minus the initial velocity squared. In particular then, we know that the acceleration is equal to the difference of the final velocity squared and the initial velocity squared divided by twice the displacement. This gives us an acceleration in the horizontal direction of 12.15 meters per second squared. So how many g's do the passengers experience in the horizontal direction? Well, we can take the acceleration, 12.15 meters per second squared, and divide it by the acceleration due to gravity. This gives us a ratio of 1.24 g's. This is pretty mild and safe. Thanks for watching.